Hey everyone, welcome back. In this video, we are doing an MCQ for AP Calc AB, Unit 1.2, which has to do with defining limits. So this question states if the limit of f of x as x approaches a is equal to L, where L is a real number, which of the following must be true? So this question is good because it makes us really understand what a limit is. So I'm just going to give a quick little talk about that. So basically, I consider the limit as what a function is approaching but does not necessarily equal. So let me just draw a quick little graph over here. Let's just say we have some quadratic function with a hole in it there like that. And let's just say this would actually be our a value, but let's just say, actually, I'll just call it a. And just if it's helpful for you, you can imagine that that's 3. And the limit of this is going to equal L. So let's put L over here. We can imagine that L is 1. Again, if that's helpful, just you have some numbers to kind of plug into your brain. But okay, so let's go through this example. So first of all, in this case, the limit would exist. And why? Well, it would exist because the limit from the right approaches L. And that limit is going to equal the limit from the left, which is also approaching L. So therefore, we can state that the overall limit exists. So it's really important to remember those conditions. For the overall limit to exist, the limit from the right must equal the limit from the left, and that's it. So now let's go through our answer choices and see which one would be true. Okay, well, A is f of A exists. In this case, does f of A exist? No, it doesn't. It would if I drew a closed-in bubble here, for example, but it doesn't have to be true, right? We could have this example here and the limit would still exist. So that's out. Now, f of x is continuous at x equals a. Well, that's certainly not true. Right here, this is not continuous. So we're going to say no to B. F of x is defined at x equals a. So again, at x equals a, which is right here, this function is not defined, right? So we're going to say no to that. And then D, f of a equals L. Well, no, again, we could, in theory, have a closed-in circle down here where f of a equaled some other value, right? It could equal, let's just call it like -5 or something. But again, we don't even have that at all. So we can definitely eliminate D. And so therefore, we're left with the only option, which is E, none of the above. So just to bring it back around, remember, for the overall limit to exist, the limit from the right must equal the limit from the left. All right, thanks so much for watching, and I'll see you in the next one.